Hi everyone, and welcome to the second of two videos going through some past exam questions on bond enthalpies. The first question we've got here is a definition. So it's asking us what is meant by the term average bond enthalpy. So this, again, we've seen this in previous videos, that it's really important that we learn these definitions. They do get quite picky about them. This one is actually one of the more simple definitions. Okay, it's the enthalpy change when 1 mole of gaseous covalent bonds is broken. Okay, so it's just the enthalpy change when you're breaking a bond, but you're breaking 1 mole of those bonds. It's always talking about covalent bonds, because an ionic bond is not really a bond, it's sort of an attraction that works in all directions. And it is always done with gaseous species. So it's quite a nice short one for 2 marks actually. Right, then we've got a calculation here. Using the average bond enthalpies, calculate the enthalpy change of this reaction. So this one's hopefully reasonably straightforward. So again, we're going to split this. We're going to look at the bonds on the left and the bonds on the right. So here we've got CH bonds. So we've got CH bond is 415. And then this is the one where I'm definitely going to sort of tick off the bonds here because it's very easy to miss one. So how many CH bonds have we got? 1, 2, 3, 4, 5, 6, 7, 8. And then I've got CC bonds, 345. I've got 2 of those. Okay, let's add that up. So 415 times 8 plus 345 times 2. We got 4010. And that's plus 4010 because that's all the bonds we have to break. Right, then on this side I've got CH bonds again. So I've got my 415. I've got 1, 2, 3, 4, 5 these as well. So I've got 8, so actually that hasn't changed. And then I've just got the CC double bond. Actually, I could have shortcutted this. These two are going to cancel out, so actually the difference is just going to be these two. But I've already calculated this, so... right, so let's work this other side out. 415 times 8 plus 611 is 3931. And that's going to be minus, because these are all bonds being formed, so it's going to release energy. So therefore, the enthalpy change of reaction is we're just going to use these two numbers, plus 4010 minus 3931. And we get 79, plus 79. And again, I think it's probably good practice to actually put the plus on. Okay, just if you can get in the habit of always writing a sign on an enthalpy change, it means you're less likely to miss a minus sign when you need one. You don't really need to write the pluses on, but you certainly do need to write minuses if it comes out as a minus. Right, then it says the actual value for the enthalpy change of this reaction is plus 81. So we're slightly off here from our calculation. Suggest a reason why the actual value is different from the calculated value. Okay. Well, the key thing for this one is the fact that we've used the average bond enthalpies. Okay. Now the average bond enthalpy is the average, but the average of what? It's the average of the amount of energy needed to break the bond from our definition, but across different molecules. So for example, we've got CH bonds here, and we've got CH bonds here, and we've got CH bonds here. These CH bonds will be slightly different strengths in these 3 molecules. Okay, not by much. It might, they're saying 415, and it might be 415 there and 416 here, but it will make a slight difference, and you can see it is only a slight difference we're looking at. Okay, so it's the fact that the average bond enthalpy isn't the accurate value for the bond in a specific molecule. Okay, so that's what we can say here. We have used average bond enthalpies which may have a different value to the bond enthalpy in a specific molecule. Okay. Right, just a couple more calculations to practice. Hopefully we'll be getting the hang of these type of questions by now. Here we've got another reaction, and it wants us to calculate the bond enthalpy for the HCl bond. So this is another one of those where we're not doing the enthalpy change. You see they've given us the enthalpy change. We're trying to calculate this bond. So we need to add up the bonds we need to break. So we need to add these two up. So 436 plus 243. Okay, I'm just going to do this on the calculator so I don't mess it up. 436 plus 243 is 679. So those are all the bonds we have to break. So plus 679 minus the two HCl bonds. These would be a negative value because they're bonds being formed. So we'd have this lot, take away that lot, is minus 184. So now we just need to rearrange this. We're going to add the 184 and add the 2 HCl that side. So 679 plus 184 is 863. So plus 863 is the 2 HCl bonds. So the HCl bond is 863 divided by 2, which is 431.5. Okay, finally, we've got one more question. Here we've got another reaction, and it wants us to calculate the enthalpy change of reaction. Okay, but for this one, again, the first thing we're going to do is actually draw out the molecules because they haven't done it for us. So I want to actually see the bonds. So CO2, let's draw this out. It's going to look like this, plus 4H2. So I'm going to have 4 lots of H. I'm going to do that just to make it clear to myself. Then I'm going to have CH4. It's going to look like this. And then we're going to have 2 H2O. So, okay, so then let's add up the two sides here like we've done before. So we've got the CO bond is 805 times 2. That's those done. And then the HH bond is 436 times 4. And that's that done. If we add that up, 805 times 2 plus 436 times 4. 3354. And that's a positive. Those are all the bonds we have to break. Okay, what about this side? We've got the CH bond times 4. That does all of those. And then we've got the OH bond, which is 464. And I've got 1, 2, but then I need to times it by 2. So that's times 4 as well. So let's add that up. 415 times 4 plus 464 times 4 is 3516. And that's going to be negative because that's energy being released when we're forming these bonds. Okay, and then the calculation is we're going to do plus 3354 minus 3516. 3354 minus 3516, and we get minus 162. Okay, that's what we're going to put here. And here we definitely need to have the minus sign.